Great. Okay, so as Andy was just saying, Cam Pro is not only available with Solid Edge, but it's free for Solid Edge. So 2.5 axis milling comes with any classic or premium seat of Solid Edge. So it's important that everybody knows that it's free of charge. So before we get going, my name is Mark Anderson. I am a subject matter expert for CAM, Siemens CAM products for Saratech. I've been in industry for about 2.5 decades now in some type of CAM solution, and I've been in Siemens products for nearly 15 years now. So here's an agenda of what we're going to go over. We're going to do the overview of the Solid Edge CAM Pro interface, how they function between one another, the description of the file structure and how it communicates between the two, the associativity factors, the link to CAM Pro on how do we go from our CAD environment to our CAM environment. Then I'm going to do a live demonstration of 2.5 axis milling while discussing the key attributes of this, the enhanced AI, the SMK smart access kits, and auto generation of toolpath. Now, I do have another item on here, it's automation. So there's a piece in CAM Pro that is called feature-based manufacturing. And you saw before where they were talking about model-based definition and the PMI data. And that's going to further touch base on that. And how can we use that data in the manufacturing environment so that we don't have to do things twice, or we can build intelligence into our tooling selection, our operation selection, and we can take what we've already done once, program it into the system so that the next time it encounters that situation, it will automatically understand how to program it. So what we're getting at is we're trying to do things once, teach the system how to understand that, and then to auto generate toolpath from that situation. And that's called feature-based manufacturing. Then I'm going to go through one of the largest attributes of the CAM Pro product that's going to set itself apart from any other third-party CAM software. And that's how do we handle engineering change orders. Now, most of our competitor softwares, the best that you're going to be able to do is create a second program with your new file and then copy and paste things, and hopefully they retain their attributes and you can just automatically generate them. In other softwares, the CAM file is embedded inside of the CAD file. So if you make a change to your CAD file, it automatically updates. That's not the same thing as associativity. That is, CAM file is embedded into your CAD file and it can only use the CAD geometry that's within that file. So that's not true associativity, that's embedded files. So what I'm going to show you with CAM Pro is we have a true associativity to where I can take a CAM file that I've already created, take a revised part, and replace that component and everything update automatically. So let's get into it. So here's a Solid Edge CAM Pro interface. On the left, you see your standard Solid Edge, and on right, you see your CAM Pro interface. So the file structure that you're going to see is when you open a Solid Edge part and then you save it in CAM Pro, it's going to create PRT files. That's just the CAM Pro extension. But there's a full associative link back to the Solid Edge file. So I have demos set up for each one of these, but I'm going to go through my entire PowerPoint first so that I'm not jumping back and forth. So I'm going to go through a comprehensive 2.5 axis milling demonstration. Then I'm going to show you the automation through feature-based manufacturing. And what this slide here shows is it shows the engine that's driving this process. What we're doing is we're asking CAM Pro to interrogate the model, find any PMI data, any features that were created out of the Solid Edge platform, like holes or tapped holes, things like that. All of those attributes and that information comes in with the solid model. So once it's found those features and it's analyzed and it's listed them here in the center column, then we're going to ask it to go a step further and say, look at the tool data library, which you've saved your tools and holders, and then look at the operation library, which is all of the operations that you have available to you within NX. And you're going to say, please pair a tool with an operation to the historical data that you've taught me and automatically program those features. So this part, what I'm going to show you is it's going to interrogate the part, it's going to find the slots, the center hole, the outside hole, and it's going to automatically produce a toolpath off of that. But this is what I'm showing you is out of the box CAM Pro. So I have not done anything to the feature-based manufacturing library to teach it any information. So what you're likely going to see is that it doesn't even have enough data, or it doesn't have the tooling data to complete the process, but you will see toolpath generated. And then the purpose of that is so that I can show you the ease of teaching into the system. So I'm going to show you the full gamut of this process, because it's important to see when you start talking about teaching a system of any kind, most users feel like it's coding, or it's something that's too deep and above CAM programming, and it's not within Solid Edge. It's a very nice user interface dialogue that you can walk directly through. And this is the process of our engineering change order. The part on the left is our original part on the right is our revised part. Excuse me. And then I'll show you the replace component command and how we handle the engineering change orders. This is a depiction of that process. This is the replace component dialog box. We simply right click our component, replace component command, browse out to our new component, and hit OK. Then we just regenerate our toolpath. Okay, so let's go ahead and go in here and I'll show you the demonstration. So you see I have this assembly open in Solid Edge. I'm going to simply hit our nice link right here. So there's a link in the title bar here, but there's also links within the tools over here in Cam Pro. So we'll hit this Cam Pro. It's going to launch out to the Solid Edge 2023 product. Now it's bringing in the entire assembly, and we're going to have to single out the component that we want to create. This is bringing in all pertinent information from Solid Edge for our interoperability assembly updating. If there was something that didn't come in correctly or something that would tell us, and it said operation has succeeded. So with this assembly, I'm going to target this one component down here. So it's a 60mm pulley, right click. Now what I'm going to do is I'm going to utilize a manufacturing template. So what a manufacturing template is it gets you into the environment of the manufacturing that you're about to do. So if we chose a general template, that's going to give us the ability to do all facets of machining. If we were to choose turning, that's going to put our pieces in position that would be indicative of turning. Our Z-axis would be facing forward to be a center line of the spindle, and the Z-axis. So this particular template is for milling. So what I'm going to do here is I'm going to assign a few items. We have to tell it, where are we touching this part off at? This is be our 0 location for the machine tool. Then we're going to say, what is our stock condition? We're saying this is our part that we're cutting to, and what are we cutting it from? For this particular example, I'm going to just choose an automatic cylinder. Sorry, let me just fix this. My Z-axis was not correct. There we go. So now when I choose bounding cylinder, it will be on the correct axis and it will encompass the part. Apologize. There we go. So bounding cylinder is going to bound any geometry that you have designated as your part. So now it understands what material it needs to be cut from. So this automatic cylinder for our blank representation is listed in our part navigator. We're going to hide that. So now that we're ready, the Cam Pro product, it understands what we're cutting to and what we're cutting from. So now many CAM systems, you would sit down and you would start to build your environment. You would say, I have these tools to work from, these pieces of geometry, and I want to use these operations with those tools. Well, with Cam Pro, you don't necessarily need to program in that fashion anymore. We can program, I call it from the hip, because I go as I go. I don't necessarily have to have that construction or constraint of the user having to be able to follow along with the program, what material is left over, where am I starting from. All of that is irrelevant anymore with Cam Pro, because it knows where material is and it knows what has been removed by the previous operation. We call that in-process workpiece. So every operation that we create, there's an in-process workpiece that's developed in the background so that the next operation intelligently cuts the remaining material. And that's how with Cam Pro we get our efficiency ratings of no air cutting, and we are always using the in-process workpiece from the previous operations. So for an example, I'm going to go ahead and just create an operation. So for this particular operation, I'll choose our planar milling. This is just our standard 2.5 axis roughing strategy. I don't have any tool, so I'm just going to go ahead and I'm going to retrieve it from our library. So CamPro comes with an extensive library of tools. And the process that I use is I just retrieve one from the library that it matches the tool that I want to use. So for this particular one, it's going to be a 6mm end mill. So we can preview this. We have all the preview tools to be able to look at, say, well, what tool am I using? We'll choose this 8. There we go. Now, one of the key factors to the tool selection would be, what are these corner radiuses? So we have all these analysis tools at our fingertips that we can go and measure the model or interrogate the model whenever we'd like. So this particular radius is 3mm. So I can use a 6mm tool in this, which is what I chose, 8mm. So we'll remove this to 6. Okay, so now we have this prediction on the PowerPoint. I had made a comment there that said the AI that's running in the background. So the AI it's analyzing what you do as you do throughout every time that you use CamPro, and it's trying to anticipate what you're trying to achieve by your past selections, and it will try to populate these. So without me having a history in CamPro here, it doesn't have much to go off of, but the more I use it, the more intelligence it's going to be. So now I'm going to designate, what am I cutting? We have all these quick tools here for multi-selection purposes. So instead of selection every single item, we have these quick filter tools that we can use. Now I want to tell it that my boundary type is closed. The tool side is on the inside of that feature. And then I'm going to tell it that my floor is the bottom of the part. Very simple. Now you see automatic programming. I didn't hit generate down here. It's because automatic generate is already running. So if I were to change a parameter, automatically generating. If I wanted to give it a depth, a Z offset, auto generating. So we have the capabilities in CamPro to be very, very intelligent if we'd like to be. The creating toolpath, generating toolpath within CamPro, it's very difficult to force the system to be inefficient. You literally have to force the system to go outside of its protocols to be able to create a toolpath where there is no material. And it's meant to be very efficient. So let's look at another toolpath. This toolpath is very efficient. You saw the toolpath that I did before. It required me to select lines. Select an area to be cut. So this is going to highlight extensively how intelligent NX is when it comes to blank material to part material. So I'm just going to hit save here so that I can delete this previous, so that CamPro is going to see the entire part and it's going to see the entire blank. Now, I haven't done anything to this. I've simply opened the operation and I've selected a tool. I'm just going to tell CamPro, do what you're able to do. And it will analyze blank to part and create toolpath accordingly. So now what happens if I were to designate materials and say I'd like to cut only this pocket and only this pocket? You'll see that the one toolpath disappears. Now, if I come here and create another operation, remember we are stock aware at all times, and I just tell it to do what it's able to do right now. With my in-process workpiece set to 3D IPW, you'll see that it's not going to do all 3 of those pockets. It's only going to do the one left, because it's intelligently looking and interrogating the model. So now how do we look at holes within CamPro? CamPro is 100% volumetric, all the same. Milling, holes, it's all the same. Create an operation. I don't know what this hole's diameter is, so we're going to use our analysis tools. So 145 millimeter. So I'm going to create hole making. I'll do a center drill. Now, one of the other features of CamPro is we can create geometry groups, meaning this hole is going to take me 2 selections on screen to create at minimal, center drill and a drill. If this had many different pieces to it, then I'm going to have a selection on screen each independent time I create a feature in that feature. What we can do is create geometry. Tell it that this is a 0.14, 1.4, I'm sorry here, 1.45 hole. Now it's asking me where? That hole. Now all of the attributes and entities of that hole is listed within this dialog. It's 17.5, 50 millimeter. So all of its attributes are listed there. Now if I want to program this, I simply select the group instead of the geometry on screen. So now I don't have to select on screen at all. So if I had 30 of those holes that took 6 tools to create, then this is a much quicker methodology of doing this. And we can do the same with milling. I could have chose these as cut areas and selected them instead of selecting on screen. So this end mill is not the right tool. We're going to go ahead and grab a center drill from the library, drilling, spot drill. Choose this 6 millimeter. Now you're going to see when I go into specify feature geometry here, I see this magenta circle here. What is that? That is the volume of material that center drill can remove. CamPro says that there's logic in the background saying that if my center drill cannot take out 2 diameter or diameter of chamfer, then there's no point in going any further than this because it's no more efficient or less efficient than just putting my center drill dimple. So CamPro is thinking for us. It's saying this is the most efficient process that can be. If there were more entities within this, if there was a chamfer, a counter bore, they would be listed in this dropdown and we could tackle each one as we wanted to. Or we can just allow CamPro to say, what is next? So if I create an operation, a drill, this time I'm just going to create a drill so you can see how it parametrically is done. So I'm going to create one. I'll do a standard drill. And you just walk through the dialog. 1.45. If we wanted to create a holder, we could do that in the holder tab, piece by piece, step by step, or we can retrieve one from the library. CamPro comes with a vast library of holders too. And what you can do with this is just select one and hit your arrow key. That's going to show you what is closest to your style of holder. Now when I go in here to specify feature geometry, you're going to see that it says I can do the entirety of that hole with this tool. Is that what you'd like me to do? Yes. So now you've seen the simplicity of how CamPro programs. Now one of the other attributes that go into what I said earlier was you don't necessarily have to think about the control of your program anymore like we once did. As a CAM programmer, we once had to sit down and have a list of our tools. What am I doing first? How much material is going to be left? I'm going to approach here. I'm going to do this. I'm going to do that. That's the thing of the past with CamPro. What we do now is we program in any sequence that we want. If this hole was on a step that had to be cut first, it does not matter. We could do that hole first because the way CamPro works is as we program means it's irrelevant to how it's going to be posted on the machine. We come to program order view here and we physically organize this in the order in which we want to output our program. So if I were to just to come up here and say, I want to do this drilling first, I can do that. And CamPro is simply going to adjust all of the attributes of the in-process workpiece before that tool is cut. So if this was at a step, it would say its approach value would go down to the step and then it would finish drilling. Everything is cohesive and it will update all on its own. So now let's look at a verify. This is how CamPro verifies its toolpath. Now, be careful when I say verify. So verify, we all know in CAM programming that no CAM software speaks Sinomeric, FANUC, Heidenhain, or any of the other controller languages. It speaks the programming software language, CLSF code. That always has to go through a post-processor of some kind to get into machine code. So when we're looking at verify here, we're looking at internal CamPro code. That doesn't necessarily mean that it's going to be the same situation on the floor until that translator, which is called a post-processor, is ironed out. Once it's ironed out, then you will see piece for piece. So let's look at this. We have full collision detection. We have gouge checking, tool holder collision checking, interference checking. We have full comprehensive checking capability with the software. Okay, now we have this analysis tool that we can come in, select on screen, no material, no material, lots of material, no material. So we have a great analytical tool here to see where we are at all times. So now, once we get to a stage where we want to see G-code driven simulation, or ISV, integrated simulation and verification, then we would use a simulation kit. So this is an example of a simulation kit. This contains the full kinematic values of the machine tool. It is above and beyond the capabilities of a Vericut solution. With the CamPro solution, we have a lot of integral pieces that perform above and beyond an external solution like that. That external solution is a circular solution, meaning you program in your CAM solution, you do your checks and your balances to make sure that you have no collisions or anything like that. But then you output G-code that goes to a third-party simulation software. That software runs through all your checks and balances, and if there is an error, it doesn't tell you where to fix it in your CAM software. You just have to go back, fix it, output, resimulate. With CamPro, it's circular, it's straight line, I'm sorry. We build our digital twin up front. So before I even started this file, I would start my file exactly as I showed you. I would add my fixture, add my machine, constrain it, build this digital 3D representation of my exact environment. Then when every time I program and I hit generate with this, there's a type of solution that happens that doesn't happen in any other solution. All CAM systems have the ability to search through several solution sets. Meaning, if I program a tool to go a distance and then a exit move of a certain type, but it hits an over travel, all other CAM systems don't have the kinematic structure within the CAM system to know that that's even triggered. With CamPro, we do. So if we tell it to go straight line, but it hits a limit, it may alter that straight line to a loop to be able to work within those confines. So we're working within a 3D twin environment so that what we see on screen is what's actually going to be seen on real life. And then when you get finished and you program, we do a simulate machine. Now, simulation is based upon the G-code, ran through a CSE driver that is built for your specific machine tool. So now we have our execution view. This is the specific G-code that's running. And we can play, and we see our full kinematic values with material removal. So this is the highest tier of solution set and capability that you can have with the CamPro solution. When you implement your PMI data from Solid Edge, you utilize that PMI data within feature-based manufacturing, and then you utilize the CamPro simulation to ensure your programs have no collisions. You get the most efficiencies out of CamPro. So now let's talk about feature-based manufacturing. Feature-based manufacturing, you've seen how I programmed this. I'm going to delete all of it. And I'm going to let CamPro do all of the thinking for me. And as a programmer for many, many, many years, it's very difficult for me to allow myself to let CamPro think for me. But after time of it proving you wrong, you get very comfortable with the solutions that it comes up with to where you don't think about, is this correct or is it not correct? The majority of the time, the solutions that it comes up with or the toolpath style that it comes up with is correct. A lot of times I have customers say, well, I'd like it to do this. Why would we, I tell them, why do we want to change something that we're unsure of if it is correct, just because we would like to see something else? So a lot of times I find that I'm the one that's incorrect, and I should have let CamPro just do what it wanted to. So now, going into feature-based manufacturing, the only things that it needs is, what am I cutting and what am I cutting it from? So with these two items selected and identified, we can now come into the feature navigator, and we can ask it. We're asking CamPro to interrogate this model and find all of these entities that are predefined within CamPro. So it's found all these different items. Now we're going to group them just for our purposes. So meaning that if I had the example I gave with the group was, I had one group in the dropdown, I selected that one hole. Well, if there was many holes, I wouldn't want one group or one feature, I'd want one group of all the features, and that's what this is doing. It's grouping anything together that can. It cannot be grouped, so great. Now we're just going to right click and we're going to create feature process. We're asking CamPro to take our tool database that we've saved tools to with holders and our operation database, the feature machining feature navigator, and we're saying put them together and give us an accurate operation that can create these features. So now, as I said, I don't have anything in this. Oh, something was incorrect here. There we go. Let me make sure I'm correct there. Now everything's right. So let's do this one more time. Find the features, create feature process. So you see at the bottom, it's pairing the two databases together, creating operations, looking at the rules of those, and it's saying, what can I do? So it's saying, I am capable of understanding these particular features, and this is the program that I'm able to create off of it. So it is intelligent enough that it knows that no rotating tool can cut this corner due to the conditions in the machining knowledge database. The machining knowledge database has a rule condition that says any corner under 20 thousandths of a radius of 20 thousandths cannot be cut by a rotating tool, and it must be cut by a wire EDM. So it even gave us a wire EDM path. So let's look at it and see what it's given us. And it's not bad for a automatic program that came out of the box with CamPro. This is what you could do this right now with your Solid Edge product. This part is actually a sample part that you can find in your samples and test this out just the same. So now what happens, that's very powerful, extremely powerful. Now let's talk about a different solution for this. Many people see this as an end solution. I try to make sure that my customers know that this is a beginning solution. Once your machinists and your programmers put in a little bit of time to feature-based manufacturing, this should immediately go into quoting. You should be able to provide quotes within 30 minutes of getting a quote, have with up to 75% accuracy when it comes to tooling, materials, speeds, feeds, depth of cuts, machining times, all of that. You could do it with a quick click of a button, and then you could take less time from engineers to say, okay, is this accurate, instead of do the entire thing. So it's a very, very powerful tool. But what happens if this isn't the way that I would like to machine my items? The speeds, feeds, depth of cuts, tooling selection isn't necessarily how we like to machine. All we do is simply reprogram it the way that we'd like to. Object, teach operation set. Now this dialog box is comprehensive. It has everything to do with that operation, your non-cutting moves, how it starts, how it stops, all of the different characteristics. And then we can even go further and say, I want this logic to be used on any type of pocket that has up to a 6 millimeter corner or 3 millimeter radius in the corners, no matter how wide, no matter how long, and up to, if my tool has 10 millimeter of flute, up to 9 millimeter thick. We simply go and change these parameters instead of saying a direct number up to this number, instead of a width or a radius up to this number. Now we're parametric with it, so it can start to understand many different item types fit one type of rule. So it's a very powerful tool. Me personally, I use this even though I don't alter it out of the box, because for Saratech doing contract programming, it does me no good to bake in processes of one particular company. So I leave it out of the box, but I always start with it because it creates my whole groups and it gives me 80% of my program to where I only need to focus on contour machining or updating some of this information. Extremely powerful tool. Oh, I'm sorry, let me finish. I need to show you one more thing. So now, as I was saying, about post-processing. So that is a caveat of all CAM systems that people immediately know that they should pay attention to, because without the correct post-processor, no CAM system will even function. So it's a sore discussion with many customers with third-party softwares on their post-processors. They're not happy with them, they don't get good support, and they're locked in, they can't do anything with them. So with CAM Pro, you have the ability to come to what we call Post Hub. Post Hub is the SMKS kit, Smart Machine Kit solution. So what this does is it allows you to not have to have the capital investment of purchasing a full-on machine tool kit that costs $20,000. You can just buy a small price book item that allows you to download, install, and use any type of post-processor or simulation kit that is in this list. There's levels to this. So there's a 3-axis, 4-axis, 5-axis additive. So if you look through this, it's loading them now. Anything that says free is available to you to use. You can have it, you can alter it, you can use the onboard tools to be able to manipulate it. Anytime that you see one that says SMKS, like this one is, if you have the item, you've purchased the runtime license, SMKS runtime license, you can download any of these tools and run the full simulation, the full post-processing, and as long as you have the SMKS license, they're yours to own. When you let go of the SMKS license, you don't have them available to use anymore. But this is a much more economical solution for many, many customers, especially starting out. So instead of saying, okay, I have this product available to me to use, I'm going to start using it, but have this humongous upfront cost to buy the post-processor simulation kits or build them yourself, you can purchase a small license, utilize them until you get the capital to be able to do that, or continue to use them. So it's a very economical way to get the most out of your tool. Okay. So now we have some questions and answers.
All right, Mark, thank you very much. That's pretty amazing, the power of this tool that comes with Solid Edge already. I mean, you can literally probably sell that package by itself, and I know Siemens does for other tools.
Yes, it is a very powerful tool that a lot don't know that they have the capability to use right now.
Right. So I have one question that came in. Can CAM Pro create a nest of parts so that a router or laser can efficiently cut out several parts at once?
So the second part of that question, yes. The first part, no. The nesting comes out of Solid Edge. So there is a piece of Solid Edge called Solid Edge 2D nesting. And if you create your layout, it can be solid model or DXF. We can then take that into CAM Pro and utilize a router or laser on.
All right, hope that answers your questions, Matt. Again, if you have any questions on what you saw today and want more detailed explanation, please feel free to contact us, and we'll be more than happy to help you out with that.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.